Hi everyone and welcome back to Dev Portal, your go-to channel for mastering Java concept. In today's tutorial, we are going to explore functional interface in Java, which is a feature introduced in Java 8, which is the foundation for the Lambda expression and functional programming. But before jumping into the functional interface, first let's briefly revisit what an interface is in Java. An interface in Java is like a contract which will define the method signature without implementation. And whatever class which is going to implement that interface, that class is responsible to provide the implementation for those abstract methods. Let me show you with the help of an example. First, let me create one interface here. Suppose I have written interface animal. And what I will do here, I will create one abstract method. So I will write void suppose make sound. This is the abstract method which I have created. And now what I will do, I will create one class and that class will implement this interface. So I will write class and I will mention suppose dog is the class name and I have written implements animal interface. So once I implement animal interface, I am responsible, or you can say this dog class is responsible to provide the implementation for this make sound method. So I will write, rather than write, I can show you first. Here you can see the error is coming. It is asking me to implement the make sound method. So let me click on that add implementation. And what I can do, I can add it here sysout statement. Sysout and I will print goof. So this is how we can implement the interface in Java. Let me show you that how we can use this method. So for that, first let me create the object. So I will write animal and let me give this a name. Suppose dog is equal to new dog. So I have created the object of dog class and the reference is animal class. So now what I will do, I will write dog dot make sound. And once I save this program and execute, you can see in the console it is printing go. So this is how we can create and implement interface in Java. One point that we need to remember is that interface enable abstraction and are the building blocks for the polymorphism in Java. That thing we need to remember. That's why we are creating interface. Now let's discuss that why do we need interface. As interface provide the way to achieve abstraction in the design, and second thing is that it will help us in achieving multiple inheritance, which is not possible with the help of classes. As we know that whenever I am extending the class, I can extend only one class, which means a child class can have only one parent class. Why this limitation is there? Due to diamond problem. Suppose two parent class is there and both parent class having one method, same method, common method, then in that case child class will know that which method it need to implement, from which parent class it need to take the implementation. And some other points are that it promote loose coupling as well, because the code is now dependent on the interface rather than on the implementation. And we can also reuse the behavior across multiple unrelated classes. Let me give you an example. Imagine you have different devices such as printer, scanner and fax. Now all these devices having sharing common method, that is start method. So this is the place where interface we can use, because the method name is common, we can use the interface and this method will be implemented by the different classes. You can say that is print, scanner or fax machine. So now let's discuss what is a functional interface. A functional interface is an interface which can have only one abstract method, but it can have multiple number of default or static methods, but can have only one abstract method. That is the feature of functional interface. Now why it is so important? Because it is the backbone for the Lambda expression and method references that are introduced in Java 8 as a feature. If we talk about the key characteristics, then it will allow only one abstract method and it can have multiple default and static methods. Along with this, it can extend other functional interfaces as well, as long as it still has only one abstract method. And to make a interface as a functional interface, we can use one annotation, that is @functional interface. This is recommended approach, but it is not mandatory to use it. So now let me show you that how we can create functional interface in Java. First, let me remove this code. And what I will do, I will create here one interface. But before that, let me use functional interface annotation here. And what I will do, I will write interface. And here interface. And here I will write my functional interface. And now let me create one abstract method here. Suppose I have given the method name as void do something. So void is the return type and do something is the method name. And now what I can do, I can use this reference here and I can use my Lambda expressions as well. So here I will write my functional interface. Okay, it is fine, my functional interface. and let me give this a name. Suppose func equal to, here I will use lambda expression and I will write sysout statement. This is the lambda expression. And now what I will do, I will use fun dot do something. I will call this function, and now let me execute this code, and in the console we will see this will print this is the lambda expression. You can see it here, it is printing this is the lambda expression. So this is how we can create and use functional interface in Java. What benefit we will get is that it will eliminate the need for creating enormous classes and make code more readable and concise. Now let's talk about this annotation which I have used at the rate functional interface. What will happen if I don't use it? Suppose if I comment this functional interface annotation, still it will work. Let me show you. Let me execute this code. You can see there is no change in the output. But what will happen if we forgot to add this annotation? In that case, it will work fine until you have only one abstract method. But if you as a developer don't know this is the functional interface, in that case what can happen is if annotation is not there, I can create another method here as an abstract method. Suppose I have written void do any task. Now this is not a functional interface anymore, but you can see it here. Here I am getting the error because now this is not providing the functionality for the functional interface. So at compile time, my JVM will check this is not a functional interface, so I cannot use the lambda expression here. That is one thing. And what will happen if I use the annotation? In that case, it will tell at the compile time itself that this is not the functional interface you have created anymore. You can see it here, only one abstract method is allowed, but you have used that annotation. It means you cannot create another abstract method. So what benefit we got is that it will provide the compile time checking as well, and it will prevent us from accidentally adding another abstract method. Now let me show you some of the inbuilt functional interface examples. So first let me remove this code. So let me remove this, and now what I will do, let me remove this code as well. Now what I will do, first let me show you the lambda expression for the runnable interface. So I will write runnable, and suppose here I have mentioned runner is equal to, and I know, and this is the runnable interface which is used to create the object for the threads, and under runnable interface there is one method, that is run method. So what I will do it here, I will provide here sysout statement and I will print suppose running. That's it. And I will call runner, not runner, run method here. So if I execute this code, what it will do, let me remove this space. So if I execute this code, what it will do, it will print running. Let me show you. So you can see it here, it is printing running. Let me open this runnable interface as well. So if you see it here, they have used at the rate functional interface annotation, and this runnable interface they are using for creating the thread object. If you don't know that what is thread and how we can create thread object, that tutorial also I have created in my channel. You can watch it out. Link I will give you in the I section. So if I come down, you can see it here, one abstract method they have created, that is run. Let me give you another example. What we can do here, we can use suppose consumer as a functional interface. So we have one consumer interface. So let me write consumer and let's expect one string. And what I can do, let me give this object a name, suppose printer equal to, and I have mentioned system dot out dot not dot double colon operator print ln. That's it. And if let me import this consumer first, and what I can do it here, I can write printer dot accept, and I need to provide one string, suppose print this line I have written. Let me execute this code and it will print this line. You can see it here. If I open this interface as well, you can see here they have used at the rate functional interface, and they have one method, that is void accept t. What t represent here is the generic not yet covered in my tutorial. I will cover in the future. For now you can understand I need to provide one object here. So let me go back. So here you can see we have used inbuilt functional interface as well. Let me show you another example that these are the inbuilt. Now let me create my own functional interface. So what I can do, I can create interface and interface, and let me give this a name, suppose calculate. And here I will create one abstract method, suppose void calculate, and it will expect two arguments, suppose int a comma int b. That's it. And to make this interface as a functional interface, I can use the annotation functional interface. And if I try to create another method here as abstract method, in that case I will get the error. Suppose print I have created, it will give me the error. You can see it here. So let me remove this method. Now I will use this functional interface inside my main method, and I will show that how we can provide multiple implementation. So let me remove this code first, and here I will write suppose calculate, and let me give this a name, suppose add. Now I am first, let me remove this unnecessary import. Now what I will do, I will use, or you can say I will provide the implementation for the add method. So what I will do, I will write equal to, and then I will provide two argument a comma b, and here what it will do, it will print sysout a plus b. That's it. And to call this method, I need to write add dot calculate, and I need to provide two values, suppose 6 comma 5. So if I execute this code, it will print 11. You can see it here, it is printing 11. Same way, what I can do it here, let me copy this, let me paste. Here I will subtract the method or subtract the values. Here I will multiply the value, and this will divide the values. And here I will print a minus b. This will be a multiplied by b, and this will be a divided by b. Let me execute the code, and you can see it here, it is printing 11. Okay, I forgot to change the method, or rather than method reference. So here I need to mention sub, here I need to mention mult, and here I need to mention div. So let me execute this code, and you can see it is printing 11, 1, 30 and 1. Let me add text as well, suppose adding numbers, and this will print the addition. Same way, let me add here as well, I will write subtract numbers, and let me add bracket, and here as well I will write multiply numbers, and let me add bracket. Same way I will add it here as well, division or dividing numbers, So let me execute this code, and now you can see it is printing adding numbers, subtract number, multiply number and dividing number. So this is how we can create our own functional interface in Java, and we can use it in our code. To summarize, a functional interface has only one abstract method, and it is enabled for Lambda expressions, method references and stream APIs. We can use functional interface annotation for better clarity and compile time safety, and we can use custom or built-in functional interfaces in our code. So that's it for today's video on Dev Portal. If you found this video helpful, don't forget to like this video, subscribe to Dev Portal, and share these videos with your fellow developers and colleagues. Notes link I will give you in the description box as well as in the comment section, so you can check it out. If you like my Git repo, you can give it a star as well. And if you have anything in your mind, you can write it in the comment section. I will read it. And till then, happy coding. I will see you in my next video.